In this lab, we're going to continue our investigation into transmission lines. First thing we're going to do is we're going to go back and open up our line 1 file from the other lab. And we're going to go find that. You do remember where you put it, right? So we're going to open that. And the first thing we're going to do before we change any of the parameters is we're going to resave that so that we don't get confused as to what's going where. Now my line 2 is already there because I've done this several times, so you probably won't get that message. I am now in line 2 experiment. The first thing we're going to change is some of the information on the actual source. So we're going to leave the source at 1 nanosecond or 1/1000th of a microsecond positive duration, but we're going to make the period a little bit longer. We're going to change that period to 20 nanoseconds, and we can just save that. We're going to change the source, internal source resistance of the voltage source. We're going to bring that down to 5. And we're also going to induce a mismatch on the load. We're going to change that to 30 to start getting some reflected waves. Now we've made all these changes. It's probably a good idea to go back and save it as line 2 with the updated information. So now what we're going to do is we're going to run the transient response again with slightly different parameters. So we're going to go back up to simulate analyses, transient analysis, and first thing we're going to do is we're going to change the display time to 20 nanoseconds. The second thing we're going to do is we're going to actually take control of how many data points. This will give us a better display. So we're going to say 500 data points. Now we're going to run the simulation. Whoop, almost forgot the output. I want to make certain that we have voltage at node 1 and node 3 selected. And we're going to simulate that. And you'll see that what we get is we get our initial pulse wave. And we don't get another initial pulse wave out of the source for 20 nanoseconds. But what we do see is we see some reflected waves. First of all, here is the voltage or the wave, the pulse that's being presented to the load resistor. And that's about 2 nanoseconds after the initial pulse from the source. So that time delay is due to the transmission line. But what we also see beyond that is we get some additional pulses. And you'll notice the time of the second pulse, or the second voltage pulse on the load resistor, is roughly starting about 6 nanoseconds. And we got another one that starts at about 10, and another one that starts about 14. So what we can take from this observation, and by the way, let me show you a couple things that might help us here a little bit. If we go to View, and on the graphic, we select Legend. This is going to help us define what color is representing what voltage. So V3 is what comes out of the source. V1, which is the red line, is the voltages seen as time progresses at the load resistor. And you'll see that a couple things. They seem to be spaced out at about 4 nanoseconds. Well, 4 nanoseconds happens to be the time it would take for a reflected wave to be emanated, and this is a reflected wave, emanated from the load resistor back to the source and then back to the load resistor. So this is the round trip path from the load resistor back to the source through that 2 nanosecond time delay, and then all the way back to the load resistor. So each reflected wave is 4 nanoseconds. The other piece of information we can get from this, of course, is that it is continually less voltage. And you keep on seeing this, and you'll even see down here just a little tiny bit of data that, of course, it's gotten so small that we can't see it very well. So this is a good demonstration of reflected waves when there is a impedance mismatch. So again, what we should probably do is go over here and save this, and I'm going to save it as line 2. Seeing I'm in the line 2 circuit, I want to save a line 2 graph, so we could perhaps print that out or use it later. And as you've seen, I've practiced a couple times. This is our page 3. I'm going to save that. So this gives you another tool to investigate the properties of a transmission line. And in this case, we're using an impedance mismatch between the transmission line at 50 ohms and the load resistor. So if you want to try different values of the load resistor to either increase or decrease the reflected wave, that might be very instructional for you. Thank you very much, and we'll see you next time.